Okay, I'm going to do a video for section 6.6, which deals with solving equations involving rational expressions. The Symposium encountered an error, so I'm not able to use that today. So I'm going to try to make a video on the board. Hopefully this will go well. Okay, so when we're looking at solving equations involving rational expressions, to solve the equations having rational expressions, multiply each side of the equation by the least common denominator of the rational expression. So when we look at number 1, it's 1 over x plus 1/4 equals 1/6. The least common denominator, we're going to find that least common denominator, which in this case is going to be 12x. So I'll multiply the first term by 12x, the second term by 12x, and then finally the last term by 12x. Now remember, if it helps you think about that, you can put it over 1 so that you realize you're multiplying fractions here. You'll cancel any common factors between the numerator and denominator, so in this case we'll cancel the x. That will leave me a 12. The second term, common factor is 4. That will leave me 3x. And in the last term, common factor is 6, and that will leave me a 2x. So when I solve this, I'm going to get that x is equal to -12. You can check that by substituting it back into the equation. Here I'm going to have 1 over, or negative 1/12, then plus 1/4 equals 1/6. Getting a common denominator there, you'll have negative 1/12 plus 3/12 equals 2/12. And you can see that that answer is a solution. So in this case, x equals -12 is a solution. I'm going to come over here to problem 2. Now we have 1 over x plus 2 over 3x equals 1/5. So my least common denominator here is going to be 15x. So I'll multiply each of those terms by 15x. And again, cancel any common factors between numerator and denominator. Here I'm going to cancel the x. That will leave me 15. Here I will cancel 3x. That will leave me 5. When I multiply that with the 2, I'm going to get 10. And here I'm going to cancel a common factor of 5, and that will leave me 3x. So when I'm finished with this, I will have that x is equal to 25/3. Again, we can substitute that in to check to make sure that that answer is correct. So I have here 1 over 25/3 plus 2 over 3 times 25/3 equals 1/5. Everyone should recognize this as a complex fraction, and you multiply that numerator and denominator by the reciprocal of that denominator. That's going to give me 3/25. And here I can cancel those 3's. So I have 2/25 gives me 1/5. So 5/25 is in fact 1/5. So that is the solution, x equals 25/3 is the solution to this problem. Now, if you'll give me just 1 minute, I will erase this and we'll go on to the next problem. Okay, let's take a look at problem number 3. I have 200 over x plus 300 over x plus 20 equals 10. Okay, the least common denominator here is going to be x. times x plus 20. Okay, we're going to multiply each term by that least common denominator. So I have x times x plus 20 times 200 over x plus x times x plus 20 times 300 over x plus 20 equals x times x plus 20 times 10. Okay, so now let's take a look. Try to make sure I get everything in there. Let's take a look at solving this equation. First term, my common factor is an x. I'll cancel that. So then I will multiply x plus 20 times 200 in the next term. Common factor between the numerator and denominator is x plus 20. I will cancel that. So I have x times 300. That gives me 300x. And then on the other side, for that last expression, I'll just multiply 10x times x plus 20. Okay. So this will give me, when I multiply this, 200x plus 4,000 plus 300x equals 10x squared plus 200x. Okay, so I can subtract 200x from both sides. They will then cancel. And now I can solve this by getting all of the terms on one side, and then I'm going to have a quadratic. So I will have 10x squared minus 300x minus 4,000 equals 0. I'm going to slide on over so we have more room to work on finishing this problem. So I'm at the point where I have 10x squared minus 300x minus 4,000 equals 0. I can factor out a greatest common factor of 10, which gives me x squared minus 30x minus 400 equals 0. And at this point, you can just ask yourself what two factors multiply to give me negative 400, but when I add them together, I would get negative 30. And you should get minus 40 and plus 10. So this factors to 10 times x minus 40 times x plus 10 equals 0. If you FOIL that back, you'll see that you will get x squared minus 30x minus 400 back. So now using the zero product property, I know that if x is equal to 40 or x is equal to negative 10, that will be a solution to this problem. So now you can substitute those back in to make sure that they both work. So go back to your original equation, 200 over x plus 300 over x plus 20 equals 10. So 200 over negative 10 plus 300 over negative 10 plus 20 equals 10. So that gives me negative 20 plus 30 equals 10. So in fact, x equals negative 10 is the solution. Then we'll substitute in 40. So 200 divided by 40 plus 300 divided by 60 equals 10. So I get here 5, and 5 equals 10. So again, when you look at this, x equals 40 is also a solution to this problem. Again, I'll take a minute to erase the board. And we'll take a look at the next problem. Problem number 4. I have 3 over x plus 6 over x minus 2 equals 12 over x squared minus 2x. So when we look at this, least common denominator, I have x, x minus 2. This factors to x times x minus 2. So my least common denominator is going to be this x times x minus 2. So again, I'll multiply each term by the least common denominator. So I have x times x minus 2 times 3 over x plus x times x minus 2 times 6 over x minus 2 equals x times x minus 2 times 12 over x squared minus 2x. Okay, so again, I want to take a look at this and cancel any common terms between the numerator and denominator here. So I'll cancel x in the first term, leaving me 3 times x minus 2. In the second term, I will cancel the x minus 2's, leaving me 6x. And in the last term, I will cancel both x and x minus 2 and that x squared minus 2x, leaving me with a 12. This gives me 3x minus 6 plus 6x equals 12. I get 9x is equal to 18, so x is equal to 2. So it appears that the solution to this problem is a 2. However, when we go back to look at that original equation, sorry, let me adjust this. To look at that original equation, 3 over x plus 6 over x minus 2 equals 12 over x squared minus 2x. If I use 2 as a solution to this problem, what will happen? Right here, I will have 2 minus 2, making that denominator equal to 0. We can't have a denominator of 0. Therefore, there is no solution to this problem. Therefore, no solution. You can write the empty set, the null set, but 2 is not a solution to this problem. Okay? In 1 minute, and we'll get on to question 5. So you can see it's important to take a minute after you've solved the problem to actually check and make sure that your solution works. Okay, let's go on to number 5. I have x plus 2 plus x over x minus 2 equals 2 over x minus 2. Again, you can see the least common denominator here is x minus 2. So I'm going to multiply each term. Now in this case, you can go ahead and group the first 2 terms because when you multiply those 2 binomials, you FOIL them. You actually are doing the distributive property on each. So I will take this first, x minus 2 times x plus 2 plus x minus 2 times x over x minus 2 equals x minus 2 times 2 over x minus 2. So in these first 2 terms, you're going to FOIL. That's going to give me, hopefully you recognize that as the difference of squares. So you get x squared minus 4. In the second term, cancel that common numerator and denominator. That's going to give you an x. And last, x minus 2, which is going to give you of 2. Did I make that problem correctly? Make sure I did. Okay, so I'm going to have this x squared plus x minus 6 equals 0. So when I look at this x squared plus x minus 6 equals 0, I can factor that to x plus 3, x minus 2 equals 0. So it appears that my solutions will be x is equal to negative 3 and positive 2. Okay, so now I want to substitute that back in to make sure that it is in fact a solution, or they both are solutions. So the first one, x is negative 3. For my first equation, I'm going to have negative 3 plus 2 plus negative 3 over negative 3 minus 2 equals 2 over minus 3 minus 2. So that's going to give me minus 1 plus negative 3 over negative 5 equals 2 over negative 2 over 5. So minus 1 plus 3/5 equals negative 2/5. So negative 5/5 plus 3/5 equals negative 2/5. Okay, so it looks like that is in fact a solution. Now we'll take a look at the second one. What's going to happen when I substitute 2 in to this equation? Look at that denominator. That's going to make that denominator equal to 0. So in this case, x equals negative 3 is the only solution to this problem. X equals 2 is not a solution. Okay, let's move on to page 2. Page 2, we're going to take a look at proportions. If you remember from advanced geometry, proportions are equations that set two ratios equal to each other, and A over B equals C over D. Remember, B and C were called the means, and A and D were called the extremes. We did something called cross multiply, so if you had A over B equals C over D, when you cross multiply, you get that the means are equal to the extremes. So therefore, A times B is equal to C times B. So we're going to take a look at solving these rational equations using this method of cross multiplying. The first example, number 1, I have 20 over x is equal to 30 over x plus 20. So now you're simply going to cross multiply. So you'll take x plus 20 times 20 is equal to x times 30, which is 30x. So we'll get 20x plus 400 is equal to 30x. 400 is equal to 10x, therefore x is equal to 10. Again, you can substitute that back in and check to make sure that that is the correct answer. So I have 20 tenths is equal to 30 over 30. Oops, that's not 10. I'm sorry. We'll make that a 40. I did not divide that well, so x equals 40. See what happens when you check, you can catch your mistakes. So I have 20 over 40 is equal to 30 over 40 plus 20, which is 60. That is true, so that makes that the correct solution. X equals 40. Okay, number 2. same type of problem. I have 2 over x is equal to x plus 3 over 5. Again, I'm going to cross multiply. So 5 times 2 is equal to x times x plus 3. That's going to give me 10 is equal to x squared plus 3x. When you have this quadratic term, the second power, you want to get all of the terms on one side, set it equal to 0, and then factor it. So I would have x squared plus 3x minus 10 equals 0. Again, you can ask yourself that question, what multiplies to give me negative 10, but would add to give me positive 3? So hopefully you get minus 5 and 2. So this factors to x plus 5 times x minus 2 equals 0. So therefore, by the zero product property, x is equal to negative 5 and positive 2. Again, take that answer and look back to the problem and make sure that that does in fact work when you substitute in that minus 5. So when you substitute in the minus 5, you're going to get minus 2/5 is equal to minus 5 plus 3 over 5. And that is, of course, true. The second one, you're going to get when you substitute in a 2, you'll get 2 over 2 is equal to 2 plus 3 over 2. And in fact, over 5, I'm sorry, which is also correct. Okay? Next one's going to be our word problem. Number 3 in this section. Says the ratio of men to women at a football game is 4:3. If there are 12,000 more men than women in attendance, then how many men and how many women are in attendance? Remember, when you have a word problem, the first thing you want to do is define that variable. So I defined x to be the number of women. Therefore, x plus 12,000 is the number of men. In attendance. Okay, so now we can set up our equation because we know our ratio is 4 men to 3 women. So therefore, I have 4 men to 3 women is equal to the number of men in attendance, x plus 12,000, over the number of women, which is x. When you cross multiply, you'll get 4x is equal to 3 times x plus 12,000. So 4x is equal to 3x plus 36,000. So x is equal to 36,000. So there were 36,000 women in attendance and 48,000 men in attendance at this particular game. Okay, on the next page, we have some true or false questions. I'm not going to take the time to write them on the board. I'll just read them and give you the answers. You might want to pause the video, answer those true or false questions, and then play the answers back after you've answered them on your own. Number 1, in solving an equation involving rational expressions, you multiply each side by the LCD for all of the denominators. That is true. Number 2, to solve 1 over x plus 1 over 2x equals 1 over 3, first change all rational expressions to an equivalent rational expression with a denominator of 6x. That's false. You don't need to do that. You can, some students do. What it does is adds an extra step. You don't need to do that once you multiply by the least common denominator, cancel those common factors, you're going to have an equation that is just a regular equation, no longer a rational equation. Number 3, extraneous roots are not real numbers. That's false. As we saw in some of the examples, we got real numbers. However, they were extraneous roots. Extraneous roots are roots that are not true. We generate them algebraically, but when we substitute them back in, there's a reason why they can't be used. Like they make the denominator equal to 0. Let's see, next one, number 4, to solve 1 over x minus 2 plus 3 equals 1 over x plus 2, you would multiply each side by x squared minus 4. That's true. That's the least common denominator, difference of squares. Number 5, the equation x squared equals x is equivalent to the equation x equals 0. That's false. And I want to actually have you take a look at this one. This is one that if you're not careful, you'll lose a solution. When you have x squared minus x equals, excuse me, let me write that correctly, x squared equals x. Some students have a tendency to just divide both sides by x, and then you might get like x is equal to 1. This actually has 2 solutions, so you might lose one if you're not careful. I have x squared is equal to x. Subtract the x from both sides, factor that, and then you will get both solutions. X is equal to 1 and x is equal to negative 1. You just have to be careful not to divide that x away because you can lose a solution there. Number 6, the equation 2 over x plus 1 equals x minus 1 over 4 is equivalent to x squared minus 1 equals 8, and that is true. If you cross multiply that, you're going to get 8 on the left, and then x plus 1, x minus 1, difference of squares on the right. Okay, what I'd like you to do is complete the homework assignment, and that is at the bottom of the note packet, page 435 to 436, numbers 7 through 79, every other odd. That's about 18 problems. Please have those ready for class for Tuesday. In the event that we don't have school on Tuesday, I will either post another video or a homework assignment. Have a nice day. If we have a snow day, have fun. And I will see you either tomorrow, in which you wouldn't watch the video, or Tuesday if you've watched the video. Have a nice day off.